Okay, in the last video, we left off with evaluating. We didn't try evaluating a derivative yet. This one will ask us to evaluate. So, this is the second part of 3-4, just to be clear. We're going to try to find the slope. The slope of a tangent line, well, that should sound like derivative to you. This means derivative. Specifically, it means the derivative dy dx. And we have this ugly equation, and instead of solving it, the idea of this lesson is we can use implicit differentiation to just get the derivative without doing a lot of algebra. So here we go. 2x plus 2 times 4, 8y, and now multiply by the hook on dy dx equals the derivative of the other side, 0. Here we go. Solve for dy dx. 8y dy dx equals negative 2x. I would have had to subtract 2x from both sides. I'll write that out now, just to make it clear for everybody. And then I divide both sides by 8y. And I get dy dx equals negative 2x over 8y. And it doesn't hurt you to simplify that. Dy dx equals negative x over 4y. Okay? It's fine if you want to use that, though. Perfectly all right. So, this is the slope of tangent line. M tan, sometimes we write. Remember that that's a number. This is a key part of lesson 2-5. This is a formula to find the slope. So we need to turn that formula into a number. So the slope at that point, sorry, that should be an x. And if you forgot lesson 3-3, that just means evaluated at. It's a useful notation. You've seen it in your calculator already. Okay? Evaluated at this point means we're going to plug in the x coordinate for x and the y coordinate for y. Okay? That's M tan. And many people may have forgotten that the normal slope, this is also something talked about in 2-5, the slope normal would therefore be the opposite reciprocal because it's perpendicular to normal, to tan, positive 8 over 3. That's it. Okay? Just be careful. Remember, we have to plug in both x and y. I've seen people plug in both for both. This is an x, this is a y. Careful how you plug it in. Alright, a little spicier now. Find dy dx and evaluate at the point blah, 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 blah. So, I want to point out that whenever you see xy, remember the product rule. Now maybe you're saying to yourself, Mr. Leven, what are you talking about? Why? Well, your algebra teacher at some point should have taught you that xy is shorthand for x times y. So we have to remember the product rule whenever you see xy, or something more complicated like x squared y. It's a necessary feature of implicit differentiation, and often the only thing I have to check for to see if they did it remotely right. See if the student did it remotely right. Derivative of x cubed, 3x squared. We're differentiating both sides. That's the first step. Now over here, to use the product rule, I'm going to break this into two parts that are both, I'm going to group the most amount of things, that's how I'm going to say it. I'm going to group the most amount of pieces together. The key idea, though, is that the x stuff has to stay separate from the y stuff. I'm going to use the highlighter instead, because I think that's probably smarter. So in orange, that's what I'll use for my first function, and in blue, which is just the y, that's what I'll use for my second function. So the product rule, which you should have started memorizing by now, is the first times the derivative of the second. Now, what's the derivative of y? You already know this. You've been doing this for years. Not years. Months. The derivative of y is dy dx. Plus the second times the derivative of the first. What's the derivative of this orange bit? The derivative of negative 2x is negative 2. It's the slope of negative 2x, the line negative 2x. So that's me doing the product rule. And that's hard, but you got to do it right. You got to do it perfectly. Plus, now we're taking the derivative of y cubed, 3y squared times dy dx. Why do I have this guy? It's the hook on. Why do I need a hook on? Because I'm using the chain rule, really. I took the derivative of the outside function. I brought the 3 down. I took the 1 off the power. I kept the inside the same, and now I need to multiply by the derivative of the inside. What's the derivative of y? dy dx. And before you forget, we have to take the derivative of the other side too. What's the derivative of 5x? 5. Cinco. Dunzo. So that would be worth about 2 points. Getting down to dy dx is another point. What do I have to do to solve for dy dx? A lot of work, frankly. I'm going to subtract 3x squared from both sides. I'm going to add 2y to both sides. Now, if it helps you, we can clean up this bit first, but we don't really need to. You should know that that's negative 2y, and that the opposite would be adding 2y to both sides. What's controlling which ones I want to move? Well, I want to keep all the dy dx stuff on one side. This is step 2. Collect all the dy dx terms on one side. So I want to leave all the dy dx stuff alone and move all the non-dy dx stuff. And if I do that successfully, I should have negative 2x dy dx plus 3y squared dy dx equals 5 minus 3x squared plus 2y. Now, over the years, I've gotten to see many students do something that's quite frankly horrible notation. And then they somehow get it right over here, which shows me they know something about algebra, they just don't know how to write it down correctly. Instead, we're going to follow my directions for this unit, which said clearly factor out dy dx. So right now we're going to factor out dy dx from both of them. We're treating it like a variable. And when you factor out dy dx, you're left with negative 2x plus 3y squared. equals, the other side stays the same. And now I can divide, everyone. I divide both sides by that group. I really wrote eccentrically big here. So we're going to shrink some stuff down. The highlighting is going to get all wacky. Close that parentheses. And we get dy dx, the derivative of y with respect to x, equals this horrible little trinomial divided by this horrible little binomial. That would be like 3 points out of 4 for this problem. And you're like, wow, 3 points out of 4. Man, geez, that was a lot of work for 3 points. So what are we forgetting? It's said to evaluate this at the point 1, 2. Okay. Please do not write equals and then start working. Write on a separate line or a separate space. Sorry, it's very annoying. dy dx evaluated at 1, 2. This makes your work much clearer and much more accurate. 5 minus 3. So 1 being the x coordinate will replace the x's. And 2 being the y coordinate will replace the y's. And this is a perfectly acceptable final answer, and I would stop here in almost every circumstance. But because it's notes and we have time because it's just a video, so that's 5 minus 3 plus 4, which is 6. That's negative 2 plus 12, 6/10 or 3/5. So the slope of this function is 3/5. Done. At that point. Careful. So if they asked me to write a tangent line, I would use this as the slope of the tangent line, and I would use that as my point, and I would use the point slope formula and be on my merry little way. That stuff's in lesson 2-5 as well. You need to review it. Last. Uh-oh. Haven't seen that in a little while. Not in the notes. So that means second derivative. And how do I find the second derivative? I take the derivative of the first derivative. Sigh. All right. We also have this little chestnut in terms of y. Sometimes we write in terms of x and y. We're basically saying cannot use y prime or dy dx in final answer. We're basically saying only you can have x's and y's. If I see either of those two symbols, it's not in terms of y. It's not in terms of x. So it's not okay. X's and y. It's usually going to be right in terms of y and x. Okay? I think that's how I wrote it in your homework for this slide. All right, here we go. So the first step to find the second derivative is to find the first derivative. So we're going to get the first derivative by taking the derivative of both sides. 2x plus 2y dy dx. Remember the hook on every time you differentiate y equals 0, the derivative of 3. Solve for dy dx. So many mistakes. Minus 2x. Divide both sides by 2y, and we get dy dx equals negative 2x over 2y. Or if you want to simplify right now, it won't hurt you, negative x over y. If you're ever yelling at me in class that this is purple and this is purple, that's why I argue with you. It's because on my screen, they don't look purple, right? They don't both look purple. On the projector, they do sometimes. All right, now, so that's the first derivative, and now I'm going to take the second derivative. Using the notation for second derivative, it looks like this, and many people forget that, especially off the top of their head. That's the second derivative written in this kind of notation. You don't remember that? That's also in lesson 2-5. Now, over here, what do we have? We have a quotient rule. So that's a quotient rule situation. I don't know. So, how are we going to do that? Well, it's going to be, I'm going to use highlighting, and I'll use green for this top function. Green and purple sure make an ugly color, huh? And orange for the bottom function. That's actually a pleasant color. All right, now, low, derivative of the high function, d high, minus high, careful, times, because it's negative with a negative, times the derivative of the low function. Ooh, derivative of y is dy dx. That's what we're talking about. We cannot have that dy dx in our final answer. We have to find a way to get rid of it. All over low squared. Now orange is really bad in this color palette. That's what I found out. All right. So now what we need to do is get rid of dy dx. Now how can I replace dy dx? We're going to use the fact that we already found dy dx over here. Specifically, we're going to replace dy dx with negative x over y. So I'll write it down just so you can see it in crystal clear detail. Replace dy dx with negative x over y. A lot of people in class get mystified when I do this, so I'm trying to be crystal clear. So the second derivative of y with respect to x is negative y plus x times negative x over y all over y squared. Okay? And that's going to be good enough for now. So, I highly recommend doing problem, give me 1 second. Doing problem 10 from assignment 2-4, so page 53, page 53, number 10. That'd be a good problem to practice this exact same technique. Just use things very carefully, and I don't know, you're bound to have a lot of fun. All right, go do some homework problems. Have a good time with that. I'll talk to you later. Bye-bye.